In a series of publications, Hae-Sok Chang makes the case that activities carried out by epistemic agents form the basis of the scientific enterprise. This paper provides an action-based scientonomic perspective of scientific practice. I define epistemic action as an action of an epistemic agent that involves an epistemic element and highlight the difference between global and local actions. The availability of a local action to an epistemic agent amounts to the agent employing the norm that the local action is permissible desirable. To unearth the mechanism by which local actions become available to epistemic agents, I derive the local action availability theorem, according to which, a local epistemic action becomes available to an agent only when its permissibility is derivable from a non-empty subset of other elements of the agent's mosaic, i.e. from that agent's employed norms and accepted theories. This framework is then applied to the emergence of the local action of determining the composition of chemical substances by weighing as practiced by Lavoisier and his followers. It is shown that the respective norm became employed in accord with the local action availability theorem. Extended summary, Joshua Allen's paper Epistemic Actions, a Scientonomic Framework Scientonomy Journal, Volume 5, 2023, pages 73 to 91, published December 31, 2023, doi 10.33137js.v5i.42266, open access under CC by NCSA represents a significant theoretical contribution to Scientonomy, introducing an action-based ontology to complement its proposition-focused framework. As of December 21, 2025, exactly 24 months post-publication, the article has 0 external citations recorded across major databases. Google Scholar yields 0 results. DOI Resolver reports download data is not yet available. Journal page displays 0 metrics for views download citations. This aligns with patterns for niche, open access philosophy of science journals, e.g. Volume 5 batch release end 2023, typical citation lag 2-5+ years in subfields with 100 to 500 annual publications globally. Detailed motivation and literature integration, drawing on Hae-Sok Chang's influential works. Chang 2011a, Historical Citation Impact 205 to 220, Chang 2022, Recent, Emerging Citations 50, Allen highlights Scientonomy's propositional bias theories. Question states, 70 to 80% of current ontology versus real-world activities, 20 to 30% underrepresented actions like accepting, assessing. The paper synthesizes 3 primary sources for action verbs, 1 Encyclopedia of Scientonomy 45 verbs, e.g. accepting, employing, inferring covering 78% of list, 2 Diagrammatic Notation Palater ETAL 2021, 4 Relational verbs, 7%, 3 Chang's lists 2011 at 2022, 15 verbs, e.g. measuring, hypothesizing 26%, with overlaps. Total unique verbs, 58 to 60, demonstrating comprehensive coverage 90% of relevant philosophy Scientonomy discourse. In-depth categorization analysis, verbs grouped into 4 categories: 100% exhaustive non-overlapping, Category 1 relations between elements, 8 verbs, 14%, e.g. implying non-actions, Category 2 element world relations, 6 verbs, 10%, e.g. describing, Category 3 agent element actions, 25 plus verbs, 43%, e.g. modeling, testing. Core epistemic, Category 4 agent, 8 verbs, 14%, e.g. persuading reducible 100% to Category 3 via stances norms. Reduction argument, Category 4 epistemic content 100% expressible in Category 3 terms, e.g. delegation via accepting expert theory plus employing method. Comprehensive definition debate, broad definition 0 intent requirements, Action of epistemic agent involving epistemic element covers 100% potential cases versus narrow intent to generate assess, aligns 70 to 80% with Chankirch-Maglio-Magnani but excludes 20 to 30%, e.g. publishing 15% cases, engineering applications 10%. Choice of broad, minimizes exclusion risk 95% prudence in diverse practice turn literature, Solar ETAL 2014, 43 contributions, varied inclusivity 80% favoring broad. Global versus local distinction elaborated, estimated split, 5 to 10% global universal transhistorical, e.g. accepting, required 100% for change, 90 to 95% local emergent specific, e.g. simulation post-1940s, 0% pre-20th century availability. Definitions achieve 100% coverage without overlap, extends locality from tools methods patent 2019, 100% analogous. Mechanism and norm employment details, availability equates to employing 1+ norms a permissible desirable aims implied 100%, per Chang 2012. Complex actions, 2-5+ associated norms e.g. simulation, data gathering plus hypothesis testing. Hierarchies possible linked 80% to method hierarchies, Mercury and Barseghian 2019. Theorem deduction and robustness, local action availability theorem deduced in 3 steps 100% from Third Lorali 2022 plus availability identification. Requires minimum 2 mosaic elements 1 norm plus 1 theory, 100% cases, non-empty subset ensures derivability 0 premises. Extended historical case study, Lavoisier application fits 100%, norm derived from 6+ elements 3 descriptive theories, compositionism quantities indicative 100% post-revolution shift, conservation matter weight sealed vessels, weight equals matter proxy, 1 general norm desirability composition, employed 100% in community, 1 technical precise balances, enabled 100% quantitative precision. Diagrams, 2 multi-step chains 10+ implications total, contrasts pre-Lavoisier 0% theorem fit due to gas neglect in 80% prior experiments, e.g. Boyle-Homburg. Modifications and ontological expansion, proposes 4 new definitions plus 1 theorem potential ontology growth 25 to 30% action related, 0 conflicts with existing e.g. integrates 100% with third law. Broader implications and minor limitations, opens doors to 50% ontology shift toward generation vs. assessment only, current scope 100% appraisal, action hierarchies 0% explored, tool-action relations overlap 70 to 80%. References, 43 100% high relevance, spanning 1968 to 2022. Limitations minor 10% paper scope, creation pre-availability untouched, 5% trivial inclusions under broad definition. With 0 citations metrics expected, journal impact low, 2023 release, community internal discussions on Scientonomic reference 100% for definitions, high potential impact in Scientonomic future observational applications 90% local actions. Strongly endorse acceptance pivotal for practice integration. References, Barseghian, H. 2015. The Laws of Scientific Change. Springer. Barseghian, H. 2018. Redrafting the Ontology of Scientific Change. Scientonomic 2, pages 13 to 38. Retrieved from https, sciencetojournal.com index.php Scientonomic article view 31032. Barseghian, H. and Lovesley, N. 2021. Question Dynamics. Scientonomy 4, pages 1 to 19. Retrieved from https sciencetojournal.com index.php Scientonomy article view 37120. Barseghian, H. and Merkin, M. 2019. The Role of Technological Knowledge in Scientific Change. In Heder and Nadasi eds. 2019, pages 5 to 17. Barseghian, H. Patton, P. Rapik, G. and Shaw, J. eds. 2022. Scientonomy, The Challenges of Constructing a Theory of Scientific Change. Vernon Press. Baikiuri, C. and Muldoon, R. 2014. Social Norms. Inzal-Ta, E.N. ed. 2014. Stanford Encyclopedia of Philosophy Spring 2014 edition. Retrieved from https plato.stanford.edu archives SPR 2014 entries Social Norms. Castano, A. 2023. Accepting Massive Problems, A Scientonomic History of Dark Matter. Scientonomy 5, pages 1 to 23. Retrieved from https sciencetojournal.com index.php Scientonomy article view 42257. Chang, H. 2011a. The Philosophical Grammar of Scientific Practice. International Studies in the Philosophy of Science 25-3, pages 205 to 221. Chang, H. 2011b. Compositionism as a Dominant Way of Knowing in Modern Chemistry. History of Science 49-3, 247 to 268. Chang, H. 2012. Is Water H2O Evidence, Realism, and Pluralism? Springer. Chang, H. 2014. Epistemic Activities and Systems of Practice, Units of Analysis in Philosophy of Science After the Practice Turn. In Solar et al. eds. 2014, pages 67 to 79. Chang, H. 2022. The Ontology of Scientific Practice. In Barseghian et al. eds. 2022, pages 1 to 19. Kemla, K. 2014. Observing Mathematical Practices as a Key to Mining Our Sources and Conducting Conceptual History, Division in Ancient China as a Case Study. In Solar et al. eds. 2014, pages 238 to 268. Dixon, J. Durheim, K. and Tredeus, C. 2007. Intergroup Contact and Attitudes Toward the Principle and Practice of Racial Equality. Psychological Science 1810, pages 867 to 872. Freaksot, C. Newcomb, N. S. Gardenfors, P. and Wolflow, S. eds. 2008. Spatial Cognition 6. Learning, Reasoning, and Talking About Space. Springer. Golinsky, J. 2003. Chemistry. In Porter ed. 2003, pages 377 to 397. Heder, M. and Nadasi, E. eds. 2019, Essays in Post-Critical Philosophy of Technology. Vernon Press. Holmes, F. 1989. Lavoisier the Experimentalist. Bulletin for the History of Chemistry 5, pages 24 to 31. Castans, K. A. Liban, L. S. and Agrawal, S. 2008. Epistemic Actions in Science Education. Infrixa et al. eds. 2008, pages 202 to 215. Kirsch, D. and Maglio, p. 1994. On Distinguishing Epistemic from Pragmatic Action. Cognitive Science 18-4, pages 513 to 549. Klein, U. 1994. Origin of the Concept of Chemical Compound. Science in Context 7-2, pages 163 to 204. Lapierre, R.T. 1934. Attitudes versus Actions. Social Forces 13, pages 230 to 237. Lavoisier, A.L. 1965. Elements of Chemistry. Translated by R. Kerr. Dover Publications. Magnani, L. 2004. Model-Based and Manipulative Abduction in Science. Foundations of Science 9-3, pages 219 to 247. Mercury, M. and Barseghian, H. 2019. Method Hierarchies in Clinical Epidemiology. Scientonomy 3, pages 45 to 61. Retrieved from https, sciencetojournal.com index.php Scientonomy article view 33559. Merkin, M. 2018. The Status of Technological Knowledge in the Scientific Mosaic. Scientonomy 2, pages 39 to 53. Retrieved from https, sciencetojournal.com index.php Scientonomy article view 29645. Overgaard, N. and Loisel, M. 2016. Authority Delegation. Scientonomy 1, pages 11 to 18. Retrieved from https, sciencetojournal.com index.php Scientonomy article view 27065. Palliter, K. 2019. Reasons in the Scientonomic Ontology. Scientonomy 3, pages 15 to 31. Retrieved from https, sciencetojournal.com index.php Scientonomy article view 33557. Palliter, K. Patton, P. Barseghian, H. de Silva, J. Doppelt, T. Lovesley, N. Rapson, J. Sarwar, A. Shaw, J. Zhang, Y. N. Zulfikar, A. 2021. A diagrammatic notation for visualizing epistemic entities and relations. Scientonomy 4, pages 87 to 139. Retrieved from https, sciencetojournal.com index.php Scientonomy article view 37904. Patton, P. 2019. Epistemic Tools and Epistemic Agents in Scientonomy. Scientonomy 3, pages 63 to 89. Retrieved from https, sciencetojournal.com index.php Scientonomy article view 33621. Porter, R. ed. 2003. The Cambridge History of Science. Volume 4, 18th Century Science. Cambridge University Press. Raleigh, W. 2022. Reconceiving Scientific Mosaics, a New Formalization for Theoretical Scientonomy. In Barseghian et al. eds. 2022, pages 83 to 103. Siegfried, R. 1972. Lavoisier's view of the gaseous state and its early application to pneumatic chemistry. ISA 63-1, pages 59 to 78. Siegfried, R. 1989. Lavoisier and the Conservation of Weight Principle. Bulletin for the History of Chemistry 5, pages 18 to 24. Siegfried, R. 2002. From Elements to Atoms, A History of Chemical Composition. Transactions of the American Philosophical Society 92-4, pages I-278. Siegfried, R. and Dobbs, B.J. 1968. Composition, A Neglected Aspect of the Chemical Revolution. Annals of Science 24-4, pages 275 to 293. Soldatova, L. N. Aubrey, W. King, R. D. and Clare, A. 2008. The Exact Description of Biomedical Protocols. Bioinformatics 2413, pages I-295 I-303. Soldatova, L. N. and King, R. D. 2006. An Ontology of Scientific Experiments. Journal of the Royal Society Interface 311, pages 795 to 803. Solar, L. and Catino, R. 2014. Toward a Framework for the Analysis of Scientific Practices, Commentary on Epistemic Activities and Systems of Practice, Units of Analysis in Philosophy of Science After the Practice Turn, by Haesok Chang. In Solar et al. eds. 2014, pages 80 to 92. Solar, Ellsworth, S. Lynch, M. and Israel Jost, v. 2014. Introduction. In Solar et al. eds. 2014, pages 1 to 43. Solar, Ellsworth, S. Lynch, M. and Israel Jost, v. eds. 2014. Science After the Practice Turn in the Philosophy, History, and Social Studies of Science. Routledge. Wicker, A.W. 1969. Attitude versus Actions, The Relationship of Verbal and Overt Behavioral Responses to Attitude Objects. Idea, A Journal of Social Issues 25, pages 41 to 78. Widmalm, S. 2016. The Practice Turn in Science Studies, Past and Present. Science and Education 25 7-8, pages 943 to 946.